Hallo und herzlich willkommen auf der Industrie.forward EXPO. Ich bin Dana Neitzke vom Published Industry Verlag und Ihre Moderatorin heute für den Vortrag Internet of Things. Auf der Industrial Solutions Stage begrüßen darf ich dabei heute Herr Talvitie, Chairman of the Board bei Nuke's Node. Hello, nice to have you here.
Thank you.
That is it from me. The stage is entirely yours now.
Thank you. Hopefully you can all see my screen. So my name is Herr Talvitie and I am representing here a company of mine called Nuke's Node. So I am a software entrepreneur and I have a long background in as a side of the software business, also in the industrial automation. This is also a very typical background of my colleagues within Nuke's Node. So we have people coming from companies like Siemens, Beckhoff, B&R, ABB, and so on. So we are a specialists when it comes to industrial automation equipments and softwares operating with or aside them. And our slogan in the slide that I'm using today, liberating machinery, is a quite bold one. But it is there for a reason. So if you remember nothing else from this presentation, I hope that you will learn today that certain technologies that are not so common yet in the industrial automation networks can significantly help us when we are taking away traditional boundaries that technology is setting us when it comes to the operational networks and industrial equipment. A little bit of our company. We are a tool. So Nuke's Cloud is a software-based tool, software-only tool, meaning that we don't have any physical products. And we have designed a toolkit to be used in the operational networks, so in the industrial automation networks. It is built on Docker ecosystem. I will explain at the end of this presentation a little bit more technically what we have done and why. The goal we have had is that this cool toolkit would give certain benefits. I call them undeniable benefits that are every day in use and well tested in the IT industry, but not so well known or used yet in the OT industry. And we try to be a bridge between the two. So I will get back to this a little bit more, but I will first focus on the use case itself that we are going to concentrate today. So when we are facing a very typical problem that our end customers or our, as a machine builder, our end customer doesn't allow us to get access to our machinery that we would need for some reason. But to be able to explain this in more detail, I need to very quickly go through the architecture that we are talking about, because it's difficult or impossible to understand what I'm going to explain in the use case if we don't first check briefly what the tool does and how it is built and set up. So in the picture now, you can see that our software is a combination of two different softwares or two different pieces of software. The one that we call an Edge app, which is designed to be a small piece of software in the operational network that in the picture I call a local network, so typically inside a factory or a lot of factories. And then we have something that we call Cloud app, could be also called Central app, so a app that is connecting all these edge apps to each other and to himself, meaning that this is the side of our tool which is used for all commands, configurations, and settings of the edge apps around the world. The Cloud app can be run in cloud, in internet, in server, but it can also be running inside the same factory as the edge app or even inside the same device as edge app, because it's all Docker based. Now, Intranet of Things was a slogan that we started to use some years ago when our customer base is basically more or less only industrial machine builders and system integrators. So very typically somebody who has built a machine and shipped it somewhere and now is trying for any reason to get an access to that device for different reasons. Today we will concentrate on the reason of troubleshooting in the cases there is something wrong with the machine. And I would say that this is one of the most typical problems that we face when talking to customers, that they have that access to the machine is for some reason denied. Now, setting up the scenario, typically you would be in the case where you have a machine and a control system of the machine running somewhere in the factory. And now I have here our sister company After.io. I have them as an example. So we have this is a tool designed for industrial machine builders, again, to run any after sales operations, maintenance or similar. And the idea is that more or less all the machine builders in the world are somehow operating or servicing their own machines that they have shipped out to the world. And they are doing maintenance. They can be scheduled maintenance. They go there a couple of times a year or something like that to check everything is okay. And they are running it in some kind of a system, some kind of a software, or just with any, let's say, operational manner. However, when you need to do something ad hoc, meaning that something happens in the site or on the site without planning so, traditionally, you would need to get a remote access to the control system. How has this been done until now? It has been done over a VPN connection. Now, VPN connection have a couple of problems when it comes to a troubleshooting case, and we can look the problem from both sides, machine builder side as well as end customer side. Now, if we start from the machine builder's point of view, the challenge of the VPN connection is that VPN connection basically gets your control system in a virtual way to the same network as your own laptop is. That's what the VPN is doing. So that allows you to log into your PLC as you would be on site, meaning that you need to have a special tooling like Siemens TIA Portal or similar to be able to get any data out from the device. You don't necessarily have any history data. You don't have a data in the format that you can quickly troubleshoot the thing, but you have to be quite knowledgeable and you need to have a special tool. So very often it is then actually an automation engineer who should be doing R&D that is helping service to troubleshoot. So we are misusing our resources and we need special tooling. And some cases, it may be that this special tooling is available only in Germany, for example, and the customer is in US, and in Germany, it's middle of the night. So these kind of problems we face constantly. If we look at it from the end customer's point of view, the scenario is also a little bit critical. The VPN is secure. So the data security point of view, this is not a problem. But when you give an access to somebody, to the PLC, you have very little or none of the control what they do, meaning that, for example, they can dig out from the log files things that you may don't want them to see, production amounts, for example, or something that can even have effect to your stock value if you're a stock listed company. So this is why this discussion is very often very difficult. What kind of an access do I even have for my machines in the first place? Now, if we start to solve this from, again, machine builder's point of view first, much more optimal way of doing troubleshooting than the VPN connection would be that automation engineer would actually do R&D and would design a different kind of views where they are collecting proper data, right data, history data, making different kind of mathematical algorithms or rules to see if something is about to fail, or in the case something has already failed, that you have enough visual tools that anybody who knows the machine and how it works can at any time, any location, see these what we call service views and troubleshoot, seeing that, okay, that curve cannot work like that. There has to be a problem here and there, or this device is not working, or however. So when we visualize the problems, the potential problems, we typically can do troubleshooting much, much faster and without any special tools. So this would be very optimal for the machine builder. Now, this is creating even bigger problem to the end customer. For end customer, this means that somebody is collecting data from his machines or from his factories and storing them somewhere. So in this scenario, of course, the data gets transferred to cloud or similar place and it gets stored there. So now we have even a bigger problem from end customer's point of view. So now we as a tool should solve this problem in one or another way. What have we done? We start from the fact that as we have the Edge app in the local network and it is running in some Linux device where the Docker is installed, it means that we can utilize the power of the hardware that the Edge app is installed to. So we are using the calculation power and memory and other, let's say, resources that the local hardware and local network is offering to us. Starting from the fact that Edge app is collecting that data from the control system, of course, but in this first step does not automatically send it out to the cloud like in the perfect case it would, but it does certain operations locally. It can, for example, do already a lot of different kind of data analytics locally. It can only send the information to the cloud that there is something wrong, not the data itself. It can, for example, open the line when there is a problem or whatever you have agreed with the end customer, but it can do even more. We have developed further that the Edge application can have a local storage of the data, so it can be from the external interface controlled, that it holds, for example, a certain data points up to 1 month. So technically, we are talking about that we have in the local network, even this software, the Edge app, is designed to work in parallel with our own cloud app. It can also fully function as a local microservice or more local software in the local network. And that means that it can do all kinds of operations. But opening an interface to this Edge app gives you also as an end customer full control to that particular Edge app. So even the Edge app is working as a pair with the cloud app, we open an interface in the local network that any software can then control the Edge app. So it can, for example, say that 1 month of data I'm storing here constantly local. Moving forward, the same interface can be used to build systems, for example, to the HMI panel of the machine or some other place in the local network controlled by the end customer, where you can have all the data points that the Edge app is reading from the system, where you can even allow or deny certain data points ever going further. And you can build things like that. You can constantly send out of these 100 data points, 57 I allow you to constantly send, or I can say that, okay, locally you can store these, send these, and when there is a problem, I can press a send button and send them to your cloud for a certain period of time where you're checking them, and then they have to be deleted first in, first out. So this technology allows us a lot of possibilities when it comes to control the local network. Trust is good, control is better, some say. Now, we can even go one step further, because the cloud app itself is also just a bunch of Docker containers. It can be also made to run in the same device or other device in the local network as the Edge app is. And only getting from the central cloud the commands, for example, when the R&D people are coming up with a new cool service view, it can be automatically distributed so that there is in the local cloud application, you have all the features that somebody has designed centrally, and then end customer can allow you, for example, a SSH or VPN connection to that local cloud app. And that means that, yes, the service engineer sitting in somewhere can use it by the browser and don't need any special tool and can still do the troubleshooting. However, the data never leaves the factory. This is just some of the examples what this technology offers to our customers. And I would like to use the last part of my presentation to answer to a couple of questions. First of them being that why is this something that for most of our customers, when we meet them and start to work with them, they start to ask that, why is this so difficult, or why aren't everybody doing this, and what is so special about you guys? And I think that very much the answer for this question is that obviously we like to say that we are so very clever, but I think that it's very much based on the fact that this is built fully software-based and on top of the Docker ecosystem. The Docker ecosystem is something that basically you can more or less say that every IT company in the world has built their systems on the Docker ecosystems nowadays, starting from the global giants like Google and Facebook, going down to any mid-sized company like ours. And the big reason for doing so is that it allows you certain benefits. The problem of it is that the OT infrastructure is not very well known by the IT specialists, and then the latest IT trends are not so very well known, and the technologies are not so very well known in the OT specialists. OT specialists. So it means that a software engineer is two different people when we are talking about IT and OT. So our job in the between basically is that we offer a bridge for IT engineers that needs help in the OT capabilities, and other ways around, IT capabilities for OT engineers where they need help. And the second question I would like to answer before we go to an actual Q&A is that why Docker? For those of you who don't know Docker, I will explain it soon, but I think that the most important thing is that we go a little bit back in history to see the background, how we have ended up to this, what we are showing today. And we have to look actually the history of IT industry, because this is a technology coming from IT industry in the first place. So I start my history from Internet. Now, Internet is something that most of you probably know quite well, and you know that it is basically a bunch of devices connected to each other using TCP/IP protocol to change information between them. And traditionally, Internet was built on computers and similar IT devices. And for the last 10 years or so, we have been starting to talk about Internet of Things. So Internet of Things is, of course, something that we would like to have all OT devices also connected to Internet and then getting the same benefits. Now, I started this presentation by saying that we see that there's so many restrictions in the OT network that we are not really getting the benefits. And the reason is that we are not utilizing the IT technologies to its end. So if we look a little bit about the history, how the IT industry has ended up here, we can see that, okay, the Internet started in the 60s for certain use. It went on then to the different kind of data transfer and the World Wide Web. But only in this millennium, it started to explode. Maybe the social media and other such applications where you have hundreds of millions or even billions of users exploded the need for very good software architecture, because you need to be able to handle huge masses. You have to be able to distribute a lot of applications around the world in a heartbeat. You have to be able to have people developing your system around the world and deploying continuously new features. And you have to be able to outsource development, and you have to be able to do a lot of other things. Utilize artificial intelligence, utilizing machine learning, so on and so on. So similar needs, and this was basically solved in IT world in two ways. Going to the microservice architecture, meaning that all the pieces of software, individual buttons that you can see in Spotify or similar, they are all individual softwares working with each other, yes, but also independently of each other constantly, meaning that if one thing breaks, everything else works. And if one thing needs to be changed, it can be changed without affecting to anybody else. And the latest development of this is actually then Docker and other container-based solutions. So Docker is an American company, yes, making a certain container technology, but there are also others, but Docker would be by far the biggest ecosystem in this industry. So lastly, as my very last slide and last topic, I would want to explain you why Docker revolutionized the IT world and what we can learn out of that when we go further with our task of bringing the IT technologies and benefits of the IT technology to the OT world. First, what Docker did. Docker made containers where they virtualized the operating system. So traditionally, softwares were built so that you needed to have, for example, a separate version of the software when it was the Windows 3.1 or it was some other operating system. And you needed to have a certain libraries and you needed to have a lot of other things on top of the actual code to make the software run. Now, Docker put all these things in the container and made this so-called virtual level of operating system, meaning that when they are deploying a software in Docker container, or when we are, it gives you basically full independency of any restrictions like operating system, what hardware is running, what infrastructure is installed to, meaning, for example, the cloud infrastructure, and also full freedom to use any kind of building blocks and technologies when building this further, including then machine learning, artificial intelligence, and so on and so on. So this is a heart and a base for any such cases that I showed earlier. So like I said, that was just one of the examples what this technology and our toolkit can do. I have another presentation tomorrow when it comes to the automated updates of the machines around the world, operating system, PLC codes, you name it. And I could have 10 more of these presentations. So if you want to know more what we can do and what this technology can offer to you, please feel free to contact us. But now I think that my 20 minutes is up, so it's probably time for Q&A.
And we already have some questions ready for you. Before I start, though, here's another little word to our listeners. Fragen dürfen natürlich auch weiterhin gestellt werden, bis die Fragerunde zu Ende ist. So, you've finished on Docker. I'd like to start on Docker. What parts of the solutions are built by Nuxnode and what is coming from Docker?
That is a good question. So all the operational functions when it comes, for example, data collection, communicating with any brand of the PLC, with any we have tens of protocols to communicate with any robot, PLC, other operational devices. And all the other actual functions are built by Nuxnode. Docker is an ecosystem and infrastructure that we have built it so that we can offer all this function in any environment. So meaning that local, global, cloud, server, inside the PC or whatever. So Docker offers us the flexibility and all the actual functionality is built by Nuxnode.
Okay. Another question, a little similar. Somebody wants to know, you mentioned Linux a lot earlier. Does it mean your solution only runs on Linux or other protocols also supported?
Linux is the most common system when it comes to Docker. So Docker compliance in Linux devices is by far the best. So Docker environment itself typically, it doesn't require, but it prefers Linux-based devices. The latest Windows versions also support Docker. And like said, as we are using Docker as a distribution channel and the ecosystem, the functionality is still done by us. So if we need to go to some difficult environment, like we have some old Windows hardware that does not support Docker, then we just need to do the actual OS work ourselves. So we cannot use anymore the virtualization of the Docker offering, meaning that we need to have special libraries and we need to have a special connection to the operating system. We have done it many times, but then it's a little bit special case because we cannot use the benefits Docker offers.
All right, so it's about the support. Well, here's a question about understanding, or that's what our question says. Sending data to a cloud, even if it's a secure cloud, it still means sending your data to another server. So how do you really make sure that this data is hard deleted afterwards or not copied by a third party?
Well, that can be, in our tool, it's a function. So it means that we take care, we like promise to the both party that it will get deleted. But I think that this question is actually very relevant because, of course, there are ways that we can open the end customer to see whether it actually is deleted or not. But that can be, of course, that is still too big of a risk. So that's why I had this last animation that in the let's say greatest or highest complexity of the system, it had gone to that far that it never leaves the factory, because there are, for example, certain legal reasons that certain kind of data just simply cannot leave the factory. So that's why it is also very important to understand the whole system, including the cloud and visualization, can also run in the local server altogether, even if you give an access to somebody outside the factory to see it, to see the visualizations, but not the data itself. So that is possible. But answer to an actual question, by making it a feature from our side and by opening a way for the end customer to see that it actually happened. And then the additional answer is that even if that is not enough, there is one step more.
It's always good. I mean, security is very important these days, especially. A lot of people are worried about it. It's not as bad as this is last year, but yeah, we still get a lot of questions about it. Another point is about the app itself. You said it's an app, so it needs a device to run. It's, again, I suppose, a Linux device to run. But how can I control who gets the app or who should get the app? Should I give it to my technicians, or is it also locally run?
So the app itself is typically designed so that it installs the machine when it leaves the factory. It can be fully, or it usually is fully then configured from the cloud afterwards, meaning that you don't necessarily, in the production process, you don't need to do anything for the app. As long as there is an app in the device, you can, by using what we call a pairing key, wake it alive. Then it's alive in the local network when your pairing key is connecting it to your central app. And then you can, from the central app, you can push all the configurations in. For example, it's this kind of machine, it wakes up and gets its configurations automatically, and then it's fully operational. So it's kind of a sleeping agent that you can wake up at any time.
Oh, okay. Well, that sounds a lot more secure than apps usually do. One final question has come up. What if there's absolutely no internet connection possible?
Yeah, actually, thank you for that question, because I think that I forgot to mention that, because obviously there are such cases as well. So there are cases like sometimes we have been in a mine, we have been in a ship, we have been in some places where there just simply is no internet. So obviously the whole system can be run in the local network, but then you can only use it in the local network. So you have to be inside the mine or a ship to be able to do that. And this is quite typical scenario. So if you have absolutely no internet connection, you can still use the local network. You can create a local network to use it, or inside one machine, you can have it running so that you, for example, take your cell phone and then you read it in the local network or however. But there is also, in that scenario, one extension that I would like to mention, because like mine is a good example, or actually ship is also. You may be that you are even weeks or months operating totally offline, and you are using the thing offline. Like in a ship, you may have a local server inside the ship and you are using it fully. But then you get to the shore once and you get internet connection for a while. So all the updates, new features of the software, new whatever you want to then ship back to the cloud or so, can be then exchanged when there is an internet. This allows, for example, such use cases that we have one of our customers doing, for example, machine learning algorithms that's collecting a lot of data from operations, which is offline. And then when it gets to this, what they call a service station, where there's an internet, they ship all the collected data to the net. And then they are constantly teaching the machine learning algorithm that makes the machine to work more optimal way. And the data is shipped to the cloud when there is a service station. And the latest version of the machine learning block as a Docker container is then shipped back to the device using Nuke's cloud tool. And it goes back to the offline operations being, again, a little bit better. This is actually the case for tomorrow that we would be looking a little bit closer in my tomorrow's presentation.
I'm looking forward to it because I'm moderating that one too. Well, and just like that, we've reached the end of this session and looking forward to the one tomorrow. So thank you again for being here today and for being here tomorrow. Und an unsere Zuhörer natürlich auch vielen Dank fürs Zuhören und ich wünsche jetzt jedem noch einen schönen Feierabend. Goodbye.